Kinetic motion. When playing soccer, your leg is putting kinetic energy into the ball. The formula for this is, here the kinetic energy equals 1/2 of the mass of your leg multiplied by the velocity of your leg as it hits the ball, squared, and this causes the movement. Projectile motion. Projectile motion refers to the motion of an object projected into the air at an angle with the horizontal. As you can see in the video, when the soccer player is kicking the ball reaches its maximum height and comes down. When the ball reaches the very top, the velocity is equal to 0. The reason why the ball did not go straight upward when being kicked, but came down to earth instead, is because the ball is being pulled down by gravity. With knowledge of projectile motion, soccer players would know that a projectile, in their case their soccer ball, travels farthest when launched at 45 degrees.
When a soccer ball is kicked along the grass surface, there is always a force applied, but opposite to that is a force called friction. Friction is caused when two opposing surfaces make contact with each other. The electromagnetic forces within each surface resist the relative horizontal motion of the objects. In this case, it is the ball and the grass. Newton's first law. The first law of motion is called the law of inertia. It states that any object at rest will tend to stay at rest, and any object in motion will tend to stay in motion, unless acted upon by another force. This other force could be gravity, wind, or any other moving object. In soccer, however, this other force is usually the soccer player's foot or goalie's hands. In this video, Parveen kicks the ball from rest and it continues moving until Tanya stops it, and then from rest it begins to move when Tanya kicks it towards the goalie, and again it continues moving until stopped by the goalie. The players use muscles in their body to create a force to move their legs and kick the ball or stop a moving ball. Because the ball is at rest, it will continue to stay at rest. If a person or object does not stop the ball, the only reason the ball will stop is because of friction and Earth's gravitational pull.
Newton's second law. Newton's second law states that the change in velocity with which an object moves is directly proportional to the magnitude of the force applied to the object and inversely proportional to the mass of the object. This can be explained by the equation force equals mass times acceleration. The acceleration of the ball is determined by the force applied divided by the mass of the object that is being moved. This simply means that if the ball has a lot of mass, it will require more force to accelerate. If the ball has little mass, it will require little force. In soccer, it is important to know this law because if you want the ball to be moving fast, you must apply more force. If you want the ball to move just a little bit, then just apply less force. Newton's third law. Newton's final law of motion states that for every action there is an equal and opposite reaction. This literally means that if you kick the soccer ball, it will kick back at you just as hard. The only reason you don't feel or realize this is because our legs have more mass, meaning more inertia, which is a resistance to move according to the physics of soccer.
Short or tall? In your opinion, who kicks the ball faster, a taller person or a shorter person? It is commonly thought that a taller person is able to kick faster than a shorter person, making the taller person better at soccer. However, in real life, the shorter person would likely have a higher leg velocity, as putting the same energy into moving a small leg compared to a big leg would result in a higher leg velocity for the shorter person. The smaller person's legs should be faster since it takes less energy to move a smaller mass. Furthermore, the laws of physics allow a shorter person with a lower center of gravity to be better able to resist falling and enjoy greater stability.
Magnetic effect. A soccer ball is simply a projectile that is flying through the air with initial velocity. The reason the ball curves is because the kicker kicks the ball at a certain angle and velocity. Once the ball's velocity drops, the magnetic effect will start to increase. The magnetic effect is the reason the ball curves through the air. As the ball spins, friction between the ball and the air causes the air to react to the direction of the spin of the ball. As the ball undergoes topspin, it causes the velocity of the air around the top half of the ball to become less than the air velocity around the bottom half of the ball. This is because the velocity of the ball in the top half acts in the opposite direction to the airflow, and the velocity of the ball in the bottom half acts in the same direction as the airflow. The airflow is in the leftward direction relative to the ball.
Since the resultant airspeed around the top half of the ball is less than the airspeed around the bottom half of the ball, the pressure is greater on the top of the ball. This causes a net downward force to act on the ball. This is due to Bernoulli's principle, which states that when air velocity decreases, air pressure increases, and vice versa. Therefore, when a soccer player kicks the ball right of center, the ball spins counterclockwise, and the Magnus force acts left, causing the ball to curve left. However, if the ball is kicked left of center, the ball spins clockwise and the Magnus force acts right, causing the ball to curve right. This is a useful strategy when attempting to make a goal, since it makes the path of the ball less predictable to the goalie as he's preparing to block the shot.